So coming here is the first question, which is actually going to test your skills. A tricky one, a complex number. Z and W are two complex numbers such that the modulus of their product is definitely 1 and the difference between the argument is pi by 2. Which of the following option is correct? Now this question is going to test everything. Now modulus is equal to 1. If you want to get rid of this modulus, we know the property by squaring here. We have this result first, which will eliminate the modulus for you. So this is the first result we will be using from here. And again we know by the property of argument of z minus w can be written as argument of z upon w, which is equal to pi by 2. Now again, to get rid of this argument, because the modulus is eliminated, now we will be eliminating the argument, then we will be able to find out these relations. So to get rid of this argument, we know if the complex number is having the argument pi by 2, that means this complex number is lying here, that is why the argument is pi by 2. That means this complex number is completely imaginary, and if the complex number z is completely imaginary, then we know the z plus z conjugate is definitely the sum of these two is equal to 0. So what we are going to do here, we are going to apply this result. This is equal to 0. So this is the second relation for us. This was the first one. Now this is actually the property I am going to use here, and I have already used it. So from here you know z into conjugate of w is equal to minus w into conjugate of z. Now we are going to replace here. So let's see what we are going to get. Again we will get here minus w z conjugate whole square is equal to 1, or from here we will get w into z conjugate is equal to plus minus iota. Now again you can see here there are two options, that is option number second and fourth, which seems to be correct. Now there is a testing part. This may confuse you, but we have to check whether the argument which is given to us, that is argument of z minus argument of w is equal to pi by 2 in which of these two cases. So let us check how to check it. Let's see here. You know from here that argument of z can be written as minus argument of conjugate of z. Now applying this property here, this can be written as argument of conjugate of z. So let us see what we are having next. This is equal to minus of argument of conjugate of z into w. Now we can take iota or minus iota. If you take minus iota here, then the argument of minus iota will be definitely minus pi by 2, and again one more minus sign is here, so that will give you the actual difference, that is equal to pi by 2. So placing minus iota here, you can see the argument of this is minus pi by 2. So definitely this is the value which is going to satisfy. So the correct option is minus iota. So let us see which one is the correct option. It is the fourth one. This is not actually satisfying. So fourth is the correct option for us. Let us move to the next problem. Next question which is coming up here is the question from coordinate geometry related to the locus. The locus of the centers of the circles which touch the circle x square plus y square is equal to 1 externally also touches the y-axis. Now this is again a very repeated problem and again an easier one. In the first quadrant there is a circle which is touching this fixed circle whose center is at origin. So let us check this first from the figure, what actually is given to us. So here we are going to draw two circles. One circle is here which is touching the y-axis and another circle is definitely this one having center at origin. So this is a fixed circle. So x square plus y square equal to 1 is this circle, and this circle is a variable circle which is touching this circle as well as y axis. Now we want to find out the locus of the center of this circle. So let us see how this can be done. Now you can see the distance between the centers, that is this distance, is changing. And what is this distance actually? The distance between the centers is equal to sum of radii. Now the radius of this is 1, but the radius of the circle which is touching the y axis is changing. But you have to find out the locus of the center of this circle. So let us assume this as h comma k. Now the distance formula, distance from the origin is h square plus k square under root, and this is equal to what? It is equal to sum of radius, that is this is equal to 1. And what is the radius of this circle? Now since this circle is touching the y axis, so definitely this is the radius. So this radius is actually equal to h. So there is no need to apply or to assume one more variable, because again you have to get rid of this variable. Now this is simply an equation in h and k, and by simply squaring this equation you will get the locus. So squaring and replacing h and k with x and y, we have so here y square is equal to 1 plus 2 h, and again y is equal to under root of 1 plus 2x, where x definitely in the first quadrant, so x is greater than or equal to 0. So first option is the correct one. Next question is from series, and there is the sum of the series up to 15 term, and first we have to find out the general term, and again related to the spatial series. Now this term which is subtracted here is easier one. So we are going to first evaluate this term. So this is sum up to natural numbers up to 15. So it is half into 15 into 16. So this will give you value 16. So 60 is to be subtracted from the sum of this series up to 15 term. So let us write the general term first. You can notice the general term, TRH term, is definitely equal to 1 cube plus 2 cube plus 3 cube and so on up to r cube, and then the denominator itself, it is 1 plus 2 plus 3 plus 4 up to r. So the sum of the cubic terms, 1 cube, 2 cube, so the cube of natural numbers, we know it is r into r plus 1, the whole square of this upon 4. So in the numerator we have this, and in the denominator simply it is r into r plus 1 by 2. Now let us solve this first. From here you will get TRH term is equal to r into r plus 1 by 2. Now applying summation on this, so the general term is half into r square plus r. So first we want to find out the sum up to 15 term of this series. So the sum up to n terms we know it is sigma r square plus sigma r, the half of it, and you know the result. This is 1 by 6 n into n plus 1 into 2n plus 1, and again the sigma or r is equal to 1 by 2. It is half n into n plus 1. So now by putting n is equal to 15, you will get the value from here, and that will be equal to 680. Now you can check it out here. The sum of this series up to 15 term is equal to 680 and this is 60. So the answer is the difference of 680 minus 60, which is actually equal to 620. So the second option is the correct option for us. Let us move to the next problem.